Okay, in today's session, we will go through the options section. Let me paste the link in the chat. So if you go to ocaml.org/docs language, that is the options page. So we're going to use this for today's session. So let's get started here. We have seen some of these examples before, so it will be like revision, but there are some new concepts that we will learn here. So now option value wraps another value or contains nothing if there isn't anything to wrap. So the predefined type option represents such values. So let's try it in UTOP. So I can do show option, and it's either none or it is sum of a type A. Okay. So we can look at some examples here of option values. I can say sum 42. This is of type int option, or we can just say none, which matches the type constructor none. Now the option type is useful when the lack of data is better handled as the special value none rather than an exception. So it is the type safe version of returning error values. So there is no confusion between regular values and absence of a value. Okay. Now let's briefly look at exceptions versus options. So if we take the function sys.getEnv from the OCaml standard library, which queries the value of an environment variable. But this function will throw an exception if the variable is not defined. So let's try that. Sys.getEnv undefined environment variable. Right, so this throws an exception saying it's not found. On the other hand, the function sys.getEnv underscore opt, okay, it does the same functionality, except it returns none if the variable is not defined. So if I do sys.getEnv opt of undefined environment variable, okay, here it returns string option none, doesn't throw an exception. We will later on look at error handling for more detailed use cases, but now let's look at some of the option functions. Most of them are provided in the OCaml standard library in stdlib.option. So the first example is using map over an option. So using pattern matching, it is possible to map over an option. So we can define a function. So you already know what map is, right? It takes a function from A to B, right? Takes type A and returns type B. In this case, we are mapping over an option, so we take A option and returning B option. So it allows us to apply a function to the wrapped value inside an option. So this example here, we have, if it is none, we just return none. If it is sum of V, what we do is we apply the function to this value in the option, right? So sum of f of V. So this is let's see the definition here, option dot map. It takes a function from A to B and an A option and returns a B option, right, very similar to the map definition. So let's take a couple of examples here. So we have option dot map takes a function, just multiplies by itself. Now I am giving an A option, which is here an integer option, sum 3. So the 3 is x here, right, and so the result is sum of 9. Now suppose we do option dot map function x into x, pass none, it just returns none. Now the next example is use of join, which will take one layer from a doubly wrapped option. So if we take this example here, we have sum of v, it will just return sum of v. If it is sum of none, it returns none, and if it is none, it returns none again. Okay. So let's look at the definition of option dot join. Okay. Now of course this is also in the standard library. So let's try this option dot join sum of 42. So the inner sum of 42 will return 42, and then sum of that 42 will return the int option sum 42. Okay, this is join. Now suppose we try option dot join sum of none, it returns none, right. So this option here, the sum of 42 will return sum of 42, sum of none will return none, and for the last case we have option dot join of none, just returns none. Okay. Now how do we access the content of an option? So there is a get function, so type A option and returns the actual value, the contents, which is A, which is inside the option. So if it is sum of V, using pattern matching here, it returns V. If it is none, it raises an invalid argument, option is none. So here we see that get throws an exception if it is none, right. Now to access the contents of an option without raising an exception, the function value is defined, which can be used. So let's see an example here. So we have option dot get, okay, takes an option and it returns the A, the type basically, right. So I can do something like option dot get sum 42. It returns the contents of the A option, it returns 42. Now let's see what is option dot value. Takes A option, it takes a default argument and returns the contents here. So we can do something like option dot value sum 42, default say 0, and it returns 42 here, which is this one. Okay. So that's the additional parameter that value requires. Okay. Now let's move on to using the fold on the option. So let's first look at the definition of fold. So takes of type none A, and then sum of B to A, and then B option, and then returns A. The combination of map and value. And you can also use it to implement a fallback logic without writing pattern matching. Right. So let's say that we have this path environment variable, and we want to return a list of strings or empty list if it's undefined. So how does this look in a pattern matching style? Let's try that. So I define path, and we say split on colon string dot split on char in, let's do opt sys dot get env opt, the path environment variable, that's what we want to get its values, and match opt with, if it is sum s, we split on colon s, none, we just return the empty list. Okay. So now if I call path, it returns the environment variable values for the path is broken down, separated by semicolon. Right. Now we can use fold. It will simplify the implementation here. So let's try this example. So we again redefine path as let split on colon string dot split on char in, I say sys dot get env, use get env opt again with path, but now we do option dot fold, and sum is split on colon, and for none it is empty. Okay. And now if I again run path, it should give me the same result, but now this code is more concise and readable. Right. You have to use pattern matching. The last example here is the bind function. It works similar to map. In the case of map, it expects a function parameter that returns an unwrapped value of type B. But in bind, it expects a function that returns a value already wrapped in an option B. Okay. So let's look at the definition here. Okay. This function A to B takes an A option and returns a B option. So we can define bind like this. You can say let bind O option dot map F option dot join. Okay. Right, it's a quick list of useful functions in option module. So to try it out in UTOP, go through the examples, and we'll continue going through some of these data structures and functions in OCaml in the next session. Let me paste the link to the YouTube channel where you will find these videos. Also the notes for today's session, the quick reference notes are also available on the channel. Let me paste that link as well. So I just pasted that in the chat. Also the GitHub link where you will find the quick reference notes is also there on the chat. Okay, with that let's stop here and we'll continue with the OCaml learning in the next data structures, the next session. Thanks for joining and listening.